Today's focus is on a real manufacturing SME that revolutionized its operations with AI-driven predictive maintenance. By leveraging artificial intelligence, AI, and the Internet of Things, IoT, even smaller manufacturers can predict equipment issues before failures occur, turning maintenance from a cost center into a competitive advantage. We'll explore how a Finnish fish processor, Heimon Kala, used cloud-based IoT analytics to boost production by 25% while reducing downtime and maintenance effort. Heimon Kala, a mid-sized food manufacturing SME smoked fish producer in Finland with over 30 years in the industry. One of the top 5 smoked fish companies locally, it faced growing competition and rising quality standards. Their operational challenges were Square 1, manual processes, critical data, oven temperatures, humidity, was logged by hand and tracked in spreadsheets. This manual monitoring was labor-intensive and prone to delays or errors. Square 2, inconsistent performance. Without real-time insights, smoking ovens sometimes ran under suboptimal conditions, affecting yield and consistency, product quality and throughput. Square 3, unplanned downtime risk. Lack of predictive insights meant maintenance was mostly reactive. The team risked unexpected equipment issues, oven malfunctions, that could halt production at inconvenient times. The company needed to increase production capacity and maintain quality to meet demand without major capital expansion. Improving maintenance efficiency and process control was identified as the key lever. Heimon Kala's maintenance was largely preventive, reactive, scheduled checks, or fixing ovens when problems became evident. This led to excess downtime and wasted capacity, and sometimes performing maintenance too late or too early. The cost of unexpected failures can be huge. Studies show unplanned downtime can cost manufacturers 10,000 plus per hour, quickly amounting to millions. For an SME, even a single day of halted production can erode margins and customer trust. With AI and IoT, maintenance becomes data-driven. Sensors continuously monitor equipment health, e.g. temperature, vibration. AI analytics flag anomalies so that technicians service machines right before a failure is likely. This minimizes downtime and maintenance costs, optimizing resource use. Industry 4.0 tech is more accessible than ever. Affordable sensors and cloud platforms mean SMBs can implement predictive maintenance at reasonable cost, reaping benefits historically only available to large firms. Heimon Kala undertook a digital modernization project for its smoking ovens, using Siemens Cloud IoT platform, MindSphere Insights Hub. This AI-powered IoT solution connects sensors from the physical ovens to analytics in the cloud for real-time monitoring and predictions. Here is what vendors and tools they built it with. First, IoT platform, Siemens MindSphere Insights Hub, an industrial IoT ecosystem for data collection, storage, and analysis, part of Siemens' Accelerator suite. Competing solutions include IBM Maximo, Asset Performance Management, AWS IoT, Monitron, Microsoft Azure IoT AI, and GE Predix, all of which offer predictive maintenance capabilities. Heimon Kala chose Siemens for its seamless integration with industrial equipment. Second, AI and analytics. The platform uses machine learning to analyze temperature, humidity, and other sensor data. It learns normal patterns and can detect deviations. While this case leveraged Siemens' built-in analytics, alternatives like AWS's machine learning services or Azure AI could similarly be used to develop custom predictive models. Third, sensors and connectivity. The ovens were fitted with IoT sensors, temperature probes, humidity sensors, etc. 8 measurement points per oven in this case. A Siemens MindConnect Nano IoT gateway device was installed to collect multi-protocol data from existing oven controls and send it securely to the cloud. Fourth, cloud deployment. Data is sent to Siemens Cloud in real time. There, AI algorithms analyze each batch's data, and the system automatically emails batch-specific reports after each smoke cycle. These reports include all critical parameters and any alerts, enabling the maintenance team to respond proactively. Surprisingly, the core integration was completed within 1 day. The implementation steps included defining data points and report templates in the Insights Hub platform, configuring each oven as an asset in the cloud system with its sensor parameters. Installing MindConnect Nano Gateway to link on-premise ovens to the cloud. This device handles different industrial protocols and ensures secure data transfer. Connecting all sensors to the gateway and verifying data flow to the cloud. Now, instead of operators manually recording temperatures, data is captured 24/7. For each batch of fish, the system logs internal fish temperature, oven supply air temp, moisture level, oven settings, etc., all automatically. Siemens platform provided out-of-the-box analytics for threshold alerts and trend analysis. The team set up rules, e.g., alert if temperature rise is slower than normal, which might indicate a heating element issue. Over time, machine learning can further refine predictions. For instance, identifying patterns that precede an oven malfunction or a sensor drift. Maintenance and production staff were trained to use the new dashboards and email reports. Instead of routine manual checks, technicians now watch for system alerts and schedule maintenance during planned downtime only when needed. The production team incorporated the cloud reports into their batch quality checks to ensure each cycle met strict conditions, improving consistency and safety. Early involvement of the plant operators was key. Seeing live data and predictive insights in action helped gain buy-in. The plant manager noted surprise at how much valuable data can be obtained from ovens that had been running for years. This cultural shift, trusting data over intuition, was supported by clear results within weeks. Within a short period, Heimon Kala achieved a 25% increase in production capacity on their smoking line. Each oven batch that previously took 4 hours now finishes in just 3 hours, thanks to optimized control and reduced downtime between batches. This means more product out the door without adding ovens or overtime shifts. Cycle time was cut to 75% of previous duration. Automation of temperature control and faster adjustments, guided by real-time data, eliminated inefficiencies in the smoking process. For example, if a temperature drift is detected, the system can prompt an adjustment immediately rather than waiting for a manual check, shaving off wasted minutes each cycle. With continuous monitoring, every batch is smoked under ideal, consistent conditions year-round, eliminating quality variations. Product safety improved as each report now verifies that fish internal temperatures reach safe levels in every batch. This data-driven quality control means fewer defects and rejects and higher customer satisfaction. While this case primarily highlighted productivity, implicit is the reduction in unexpected downtime. The maintenance team can now address issues during scheduled maintenance windows. For instance, if a heating element's performance degrades subtly, the AI flags it early, so it can be replaced before it fails during production. The company has effectively moved from firefighting to planned maintenance, avoiding costly emergency repairs. Maintenance costs saw a meaningful decline, estimated as on 30% reduction in maintenance-related expenses, as the company moved away from frequent manual inspections and prevented major breakdowns. Technicians spend time where it truly matters, guided by system insights rather than routine rounds. The productivity boost directly translates to revenue. A 25% output increase with existing assets is equivalent to what might have required major capital investment, new ovens or extra shifts, previously. This project thus generated a high ROI, potentially on the order of 10x or more, considering minimal implementation cost versus the value of increased production. Industry benchmarks show predictive maintenance can reduce maintenance costs by 25 to 30%. Heimon Kala's experience aligns with this. Less unplanned downtime meant lower scrap and rework costs and fewer expensive emergency repairs. Over a year, those savings are significant for an SME. Operating equipment under optimal conditions and addressing issues early tends to extend asset life by 20–40%. The ovens, now carefully monitored, experience less stress, no overheating or overuse, which likely means they'll last longer before requiring overhaul or replacement, another long-term financial gain. Overall equipment effectiveness, OEE, improved with higher availability and performance. For example, downtime events that would have halted production were averted, contributing to an uptick in OEE. One automotive manufacturer avoided a 2.1 mm loss by catching a failing bearing early via predictive maintenance. Similarly, our SME avoided smaller-scale stoppages that are big for their size. Though hard to quantify in ROI, predictive maintenance also reduced the risk of safety incidents. By foreseeing malfunctions, e.g., preventing an oven overheating event, the company protects workers and stays compliant with food safety regulations. This lowers liability and potential downtime from accidents or inspections, an important peace of mind benefit for management. IoT sensors are increasingly affordable. Basic temperature sensors can cost $100 each, while more advanced vibration sensors might be $500 to $1,000 each. In this case, Heimon Kala leveraged existing oven sensors and added a few new ones, keeping sensor costs manageable. The IoT gateway, Siemens MindConnect Nano, is a small industrial PC. Such devices typically run a few $1,000s. Cloud-based predictive maintenance platforms operate on subscription models. Siemens MindSphere offers tiered plans. Heimon Kala used an Insights Hub capability package for data storage, asset configuration, and rule setting. Costs depend on data volume and features. For an SME, this could be in the hundreds of dollars per month range. Competing options: AWS IoT, EE, Amazon Monitron, charges roughly $50 per sensor per year for cloud monitoring, and Microsoft Azure or IBM have SaaS pricing that can start at a few hundred per month for small deployments. If in-house skills exist, installation can be done by staff, as in one day for this case. Otherwise, SMEs might hire a systems integrator or consultant. Integration services could range from a few $1,000s for a simple pilot to $20K plus for a broader rollout. Heimon Kala partnered with Siemens experts but kept scope limited, 3 ovens, to control integration time and cost. Investing in training employees on the new system is crucial. This cost is mostly in time, initial training sessions, and ongoing learning. In an SME, reallocating a maintenance engineer's hours to learn the new system instead of other duties is an implicit cost. Some vendors include training in their packages. Otherwise, budgeting a few days of staff time or a few $1,000s for vendor training sessions is wise. Ideally, the existing maintenance team can absorb this role. In some cases, SMEs may appoint a reliability engineer or use a third-party monitoring service. Hiring a full-time specialist with salary $80K may not be necessary for small setups. Often, the software's AI will handle data analysis, and only exceptions need human review. In Heimon Kala's scenario, their plant manager and a few technicians split these duties, incurring minimal additional labor cost. For a small manufacturing operation, say 5 to 10 critical machines, initial setup might cost on the order of $10K, $50K, hardware, setup, and first year of software. Heimon Kala's pilot likely leaned toward the lower end, given the small scope and fast deployment. This cost is often recouped quickly. Recall the 10x ROI figure. Every $1 invested in predictive maintenance can return $10 in savings or increase production. Here is the 5-step key process to successful implementation. Lessons learned. Step 1. Start with a targeted pilot. The company focused on its smoke ovens, a critical process with clear pain points. Selecting a high-impact area to pilot predictive maintenance helps demonstrate quick wins. This focus kept the project manageable and results measurable. Step 2. Leverage vendor expertise. As an SME, Heimon Kala took advantage of Siemens' ready-made solution and support. They didn't try to build everything from scratch. For SMBs, using proven platforms, Siemens, IBM, AWS, etc., and seeking help from those vendors or partners accelerates the journey and reduces risk. Step 3. Data quality and integration. The project shows the importance of capturing the right data. By connecting 8 different measurements per oven to the cloud, the company ensured a holistic view of the process. SMEs should audit what sensors data exist and fill gaps, add sensors if needed, to enable robust, predictive analytics. Integrating with existing systems, PLCs, CMMS, also avoids silos. In our case, data flowed into reports that directly informed maintenance scheduling. Step 4. Executive and team. Buy-in. Change can be met with resistance. Here, leadership recognized digitalization as critical for competitiveness and set the vision. They also involved the plant manager and operators early, who then became advocates after seeing the ease of automated data collection versus manual logs. Cultivating a culture that trusts data and encourages upskilling in digital tools is essential. Step 5. Iterate and scale. After initial success, the next step is scaling. The company can expand predictive maintenance to other equipment, e.g., refrigeration systems or packaging lines, using the same platform. For other SMEs, the lesson is to treat predictive maintenance as an ongoing program, not a one-off project. Continuously refine the AI models with new data and extend coverage to more assets for greater enterprise-wide impact. So why predictive maintenance matters for SMBs? Because competitive edge. This case demonstrates that small and mid-sized manufacturers can achieve big wins with AI-driven maintenance. By slashing downtime and boosting output, an SME can level the playing field with larger rivals through operational excellence. Predictive maintenance is becoming a must-have in the Industry 4.0 era to stay competitive. Second, the matter for tangible ROI. The outcomes, 25% more production, improved quality, cost savings, speak for themselves. Predictive maintenance isn't just tech for tech's sake, it directly improves profitability and service delivery. On-time orders, consistent quality. Many adopters see payback in under a year, given the maintenance cost reductions and productivity gains. Also, scalability. Start small, prove value, then scale up. Modern solutions like Siemens Insights Hub or AWS Monitron are scalable and flexible. You can begin with one machine and expand to dozens with cloud infrastructure that grows as you go. This modular approach fits SMB budgets and resource limits. For decision makers, the question is no longer, should we invest in predictive maintenance, but can we afford not to? Embracing AI and IoT for maintenance can extend equipment life, prevent costly failures, and free up your team's time to focus on innovation rather than firefighting. The technology is accessible and proven. As we saw, even a small fish processing company can become a data-driven leader. Consider conducting a readiness assessment of your operations. Identify a pilot asset, explore IoT sensor options, and engage with a trusted vendor or consultant to outline an implementation roadmap. The journey to predictive maintenance is incremental, but it begins with that first sensor and a willingness to harness your data. Your machines are likely telling you valuable information. It's time to start listening. Thank you.